Here is an assignment problem. This is from page 615, problem number 7 from chapter 15. So we have a police department that has 5 detective squads, and there are 5 open crime cases that are available. Now you can assign any squad to any one of the cases, but you can only assign one squad to one case. So the chief wishes to assign the squad so that the total time to conclude the cases is minimized. So the average number of days based on past performance for each squad to complete each of those cases is given below. So each squad is composed of different types of specialists, whereas one squad may be very effective in one certain type of case, it may be almost useless in others. So solve the problem using assignment method. Now when you set this up as a Excel solver problem, now question B becomes really very easy to incorporate. So assign squads to the above cases, but with the constraint that squad 5 cannot work on E. Okay, so first let's do A. Now all we have to do is to set up a shell file like this. So you have the 5 squads, and you have the 5 cases, and here is the average number of days for each assignment. Now we're going to set up a linear programming model where we'll use this as the changing cell, and we'll use this convention. If there is a 1 in a given cell, then that assignment will be made. Like for example, if there is a 1 here, then squad 1 will be assigned to case A. If there is a 1 here, for example, squad 4 will be assigned to squad C. So in that case, if you sum across each row, that sum should equal 1, because you want to assign each squad to only one case, and not more, not less. So let's sum this way, copy that, and put the bottom border back. Now similarly, each case must be assigned to only one squad. So let's sum column wise and copy that. Now the total time for the assignments that we make will be a sum product of all the assignments that we make. Okay. Most of them will be 0, and the ones are the assignments actually made with this, and that will then zero out all the non-assignments and multiply the value of the average number of days by 1 for only the assignments made. So this will give us the total time for the assignments made, and this is what we need to minimize. So let me color code that like that. Okay, so now we go to solver, and we say that needs to be minimized. Okay, the total time must be minimized, and we want to do that by changing cells. Is this? Okay, and we have to add constraints now. Now that must be equal to 1, so that will be one set of constraints, and this must also be equal to 1. Now you have to make sure that this is simplex and make unconstrained variables non-negative. There's only one problem. Now how are we sure that these will be exactly 0 or 1? Why can't it be like 0.5, 0.25, 0.25 adding up to 1? But it turns out that because of the structure of the problem, that will never happen. It will always be either 0 or 1 because of the nature of the model. And that is very convenient for us because it's going to be only zeros or ones. So 0 means not assigned, 1 means assigned. So now we solve and make sure that the solver has found a solution, and you see these are the assignments made, with 28 being the total time. So now let's add the constraint for B, which is that squad 5 cannot be assigned to case E. Now, we can do that by simply adding a constraint that that cell must be equal to 0. Now that will force solver to make that into a 0. See? In that case, your total time jumps from 28 to 46. So now we can, for B, the assignment is as follows. Assign squad 1 to case C. Copy. Then assign squad 2 to case D. Assign squad 3 to case B. Assign squad 4 to case E, and assign squad 5 to case A.